Hello all, let's continue laws of motion. In the first video of laws of motion, we studied about Newton's first law and its application. Let's revise it a little. Newton's first law being defined as law of inertia, and any object will remain in its original state of rest or continue to be in state of uniform motion unless and until acted upon by an external force. So this was Newton's first law that we studied in detail. And now we'll move towards Newton's second law. So moving towards Newton's second law, which is known as law of acceleration. See, in first law, we saw that anything we need to apply force to change its state of rest or uniform motion. So the second law is all about how much force we require to move an object or to stop an object from its motion, right? So the second law states the acceleration of an object. Acceleration of an object is in motion is directly proportional to the net force. Very important term, net force, acting on the object inversely proportional to its mass. Okay, right. What it is actually, F if we say F is a force, then we'll say F is directly proportional to acceleration. Or inverse case, actually, no, not like this. We are having that acceleration is directly proportional to force, and acceleration is inversely proportional to mass. Actually, for a particular object, we are having a constant mass. So for acceleration, we will be having F is equal to ma, mass into acceleration. F is equal to ma. This is the basic mathematical term of Newton's second law. Actually, how this works is this is if we make a graph of of an object in motion or for which we have applied an external force to make that object in motion, with what acceleration that object will move is directly proportional to the force. If m is constant, it does not change, then this is force, this is acceleration. So we are having a straight line graph, straight line graph, straight line graph, right? This would be a straight line graph. This is the direct proportionality. So this is what is second law. Second law is all about defining the quantum of the force. Right. What first law is defining how we require force. We require external force. What second law is defining what force we actually require. Now there is one term where we have having net force. What is net force? This is an object which we need to move. Right. Now we are applying this much of force, big force, and this small force from this side. So what the resultant force will be, that will be this, but this F1 and this F1. This resultant force F would be big F minus this small f, big F1 minus small f1, right? So this will be the resultant force, and this resultant force will define how much acceleration that object will take, and this acceleration will define its speed or velocity, right? Acceleration is something which will define velocity instead of speed. What is the difference between speed and velocity? Is speed with its direction. When we define speed with a direction, that is known as velocity, and that velocity of an object is defined by acceleration, right? Higher the force applied, higher is the acceleration, higher the force applied, higher will be the acceleration, so higher will be the velocity. Velocity is nothing but speed with direction, right? So this is Newton's second law. Now we can go towards the application part of the second law. There are lot many applications of second law of motion and Newton's second law or law of acceleration. And these applications are not limited to, but are there are very important applications. They are not limited to what I am defining here. There are a lot and lots many applications. I'm talking about one is here spacecraft. First is spacecraft. Then second is seat belt. Seat belt. What should be the strength of the belt to stop we people to get hurt, right? That provides some strength. सीट बेल्ट शुड नॉट बी लूज सीट बेल्ट जो है वो लूज नहीं होनी चाहिए वो उतना उतना टाइट होना चाहिए कि हम आगे को डैशबोर्ड टच ना करें राइट तो वो कितनी फोर्स होगी कितनी स्ट्रेंथ होगी उस बेल्ट की वो डिफाइन करता है कितनी टाइट होगी वो बेल्ट वो डिफाइन करता है किससे डिफाइन होता है वो लॉ ऑफ एक्सेलरेशन से ठीक है देन स्पेसक्राफ्ट की हम बात कर रहे हैं स्पेसक्राफ्ट को लॉन्च करने के लिए हमें कुछ एनर्जी कुछ फोर्स की जरूरत होती है वी नीड सम फोर्स वी नीड सम एक्सटर्नल फोर्स डिपेंडिंग ऑन द मास ऑफ द एयरक्राफ्ट larger is the mass larger is the force required to have a larger acceleration, right? Because if mass is higher and we apply some force, acceleration would be lower. So if our mass is huge, we need to apply huge force to have a corresponding or desired acceleration to put the spacecraft into orbit, right? Then third one is speed of vehicle I was talking about in first law also that we need external force. Now, how much external force is here, right? How much we need force is what we are defining from acceleration, right? We give some acceleration to the vehicle with accelerator. We are having three things, clutch, brake, and accelerator, right? So we accelerate the vehicle with the help of gears with the help of gears and how much force is required, how much brake is required to stop the vehicle, right? And that is also depending upon the acceleration of the vehicle at that point of time, right? Sometimes we are having a very sharp brake and sometimes we are having a very smooth brake, right? We are not having a very harsh brake or jerk, right? We are having very smooth brake. The third thing is then we have this speed of vehicle. Then third one is speed of vehicle, and fourth one we are having in sports, right? In sports, in cricket, we have to hit a six. We need to we are having a ball. We need to give the direction to that ball. We need to hit that ball so hard and with in a particular direction so that that ball reaches the boundary, right? It either becomes a six or a four, or it gains so much of acceleration that it travels some distance so that we can have a run between the wickets, right? Then another application is elevators. Elevators. You must have seen in elevators. We are having a mass limit, right? We are having a limit. This is the 800 kg, right? Or 1000 kg, right? Why it is written, right? It is set on some acceleration so that we don't feel that thirst of the gravity so much that we are getting from one floor to another. So this is the mass that they have decided, they have written it on it, right? This is the application part. Then we are having circular motion, centripetal motion. This is the centripetal force, right? That we have to keep it in motion. This is the centripetal force, right? This is actually force is this, and this is the direction of the force, right? So these are perpendicular actually, right? We'll have it in some other class, but this is the centripetal force that moves towards center, right? So this motion, this speed is also the application of Newton's second law of motion, right? And we are having weightlifting. We do weightlifting, and our fitness depends on how much weight we use while lifting the weight or doing exercise in a gym, right? Then we are having cranes, bulldozers, excavators, the amount of force required to move some heavy objects or like, right? So lifting objects. So this is something that Newton's second law is having applications in. There are lot many applications of these laws. There is one thing that is left that is very much important, and that is the application of what we read at that point of time, F is equal to ma. What is the major derivation of these laws was the universal law of gravitation, which was it was right? It was Gm1 m2 by r square. This is r, right? Gm1 m2 by r square. This is the derivative of this one only, right? This is the acceleration for this object and vice versa. For m2, m1, m2 will be here and that would be the acceleration, right? Then the third one is uh, this work energy equivalence, right? Work energy equivalence. We are having work done is equal to work or energy released or used. Energy is used while work is done, right? So that would be F into S. S is the distance, right? Distance traveled by the object, and this is the force. Force is ma, right? So this is it. So this work energy equivalence is also one of the applications, one of the derivatives of this second law of motion, right? So this is all about first and second law of motion. Now we'll move towards the Newton's third law, which many people think is very easy also. So the third law of motion will move towards, right? So in the first video, we studied about Newton's first law, and now in second video, we studied about Newton's second law. And for the purpose of revision, we have again put this definition, and this is the acceleration of an object in motion is directly proportional to the net force acting on the object and is inversely proportional to the mass of the object. So this is Newton's second law, law of acceleration. We'll study Newton's third law in next video. Thank you.